Please WhatsApp me on this number. Those who join. Those who join can WhatsApp me on this number. And just check if everything is fine. Audio, video. मेरे मैसेज करो फटाफट. I'm waiting. Let's start. Okay. We will be revising electrochemistry. Okay. In the case of electrochemistry, the electrochemistry deals with the interconversion of electrical energy to chemical energy and vice versa. Okay. Either we generate the electricity using the chemical energy, or the electrical energy is used to bring about the chemical changes. Okay. Now, when we generate electricity using chemical energy or using the chemical change, normally this is done in the case of your galvanic cell. Okay. And when we bring the chemical change using electrical energy, the device which we use here is the electrolytic cells. Right? Okay. Now, okay. In this case, the spontaneous? Okay, that means the delta G, gives free energy, is negative for the reaction. Okay, and here in this case, the delta G is positive. That means the reaction cannot take place on its own. Okay, so here the reactions are non-spontaneous. Okay, so the reactions are made spontaneous with the help of electrical energy. Okay, that means unless we pass the electrical energy, there will be no conversion of the reaction into product will be taking place in this case. Okay, and here the moment we complete the circuit, the reaction will take place on its own. Okay, as a result, the electrical energy will be generated. Now, when we say that electrical energy, whether we are here or here, okay, that means some kind of electron, okay, some kind of electron transfer must be taking place here. Okay, that means whenever we have the electric energy, whenever we have the electrolytic cells, okay, whenever we have the reaction taking place in the electrolytic cell, or we have the reaction taking place in the galvanic cell, okay, these reactions are redox in nature. Okay, these reactions are redox in nature. Okay, so basically all the electrolytic reactions or the electrochemical reactions, okay, whenever they take place, they are always redox in nature. Okay, that means reduction and oxidation will take place. Okay, there has to be some give and take of electron taking place. यहाँ पर जो है एक्सटर्नली इलेक्ट्रॉन सप्लाई किया जाता है और यहाँ पर जो है इलेक्ट्रिक जो इलेक्ट्रॉन्स है वो केमिकल एनर्जी से जनरेट होता है, ठीक है, एंड द इलेक्ट्रॉन ट्रांसफर is done externally, okay, and that external transfer of the electron is used as the electrical energy. Fine. So basically, the electrochemical reactions, they are redox in nature. Okay, so there is always some kind of transfer of electron taking place. Fine. So basically, the reactions taking place in the galvanic cell, they are spontaneous, and the reaction taking place in the electrolytic cell, they are non-spontaneous. Fine. Okay. And here, in this case, the transfer of electron which takes place, or the redox reactions, the redox reaction which takes place here are direct redox reactions. Direct redox reaction. Okay. And here, in this case, the redox reaction are indirect redox reactions. What does it mean? In this case, the substance which is undergoing oxidation and the substance which is undergoing reduction, they are in the same container. Okay. And here, the oxidizing agent and the reducing agent, or the substance which is undergoing oxidation and the substance which is undergoing reduction, they are separate. Okay, they are separate and they are somehow connected. Okay, and the transfer of electron takes place indirectly in this case. So these reactions, the reaction taking place in the case of galvanic cell, they are basically indirect redox reaction, whereas the reactions which take place in the case of your electrolytic cell, they are the direct redox reaction. Right? Now, before we start with the galvanic cell, explanation of the galvanic cell, we need to understand what are the various terms which are related with the galvanic cell. Okay, we'll be discussing galvanic cell first. Okay. Now, okay. The first thing that we deal with the galvanic cell is the electropotential. Okay. the electrode potential. Now, what is this electrode potential? Now, let us suppose we take a reaction here, Fe plus CuSO4 giving FeSO4 plus C. Right? This is a redox reaction, is it? Now, let's suppose we take a container. We take a container in which we have the copper sulfate present, CuSO4 is present. ठीक है, कॉपर सल्फेट present है यहाँ पर फिर तो हमने क्या करना इसमें we have dipped iron down again, right? Now in this case what will happen? The iron will lose electron to become Fe plus plus, okay, plus 2 electron will be lost, and the copper from the solution will take up those 2 electrons and deposit as copper solid, right? So we have both the substances present in the same container. The one which is giving the electron and the one which is accepting the electron in the same container. Okay. Now, if we separate somehow, okay, then we will get the galvanic cell constructed because the transfer of electron will be externally via the metallic wire, okay, and that we can use as electrical energy, right? So, इसमें जो है electrode potential क्या है? We'll try to understand that. Now, we separate these two processes, okay. The substance which is undergoing oxidation, we separate that one from the substance which is undergoing production. Okay, so in that case, let us suppose we can take any of the substance. Okay, let us suppose here is a container in which we have zinc sulfate present. Okay, and in this one, we dip a rod made up of zinc. Fine. Now, this is the reduced form, and this is the oxidized form. Okay. So whenever we have such type of the pair present, in which we have oxidized and the reduced form present, we call it as the redox couple. Okay, this is called your redox couple. Okay. Now, in this arrangement, we can have the two processes taking place. Either the zinc from the rod will go into the solution as zinc ion, okay, or the zinc ion from the solution will deposit here as zinc solid. Both these processes can take place. Okay. Now let us discuss this one by one. Now let us suppose we have the oxidation taking place here. The zinc is going into the solution as zinc ion. Okay. The zinc is going into the solution as zinc ion. Okay. Fine. The other possibility is the zinc ion from the solution takes up 2 electrons and deposits as zinc solid. Huh? Now let us discuss first here. Now, if the zinc is going into the solution as zinc ion, what will happen? The electrons which are removed, they will accumulate here. And the solution, in that case, the solution, because the zinc is going to the solution, so the zinc will be, solution will become positively charged. Okay, and let us suppose the reverse process also may take place simultaneously. It's not that only the zinc can go into the solution. Okay, there might be some of the zinc ion from the solution. Okay, taking up the electron and depositing as zinc solid. Okay, the reverse process may also take place, is it? And ultimately, what will happen is an equilibrium will be established between the zinc, which is present here in the reduced form, and the zinc ion, which is present here in the solution as the oxidized form. Okay, so we will have an equilibrium established here. And when the equilibrium is established, we'll see that the electrode is negatively charged with respect to the solution, which is positively charged. Fine? A difference of potential is set up. What is happening? A difference of potential is set up. Okay? So between this one and this one, I hope it is visible. Okay? A difference of potential sets up. Okay? A difference of potential sets up here. Fine? Now, this difference of potential between the electrode and its ion in the solution is called the electrode potential. Okay? So this difference of potential between the electrode and its ion solution, that is called the electrode potential. ठीक है? अब जो ये electrode potential है, ये दो टाइप के हो सकते हैं. ठीक है? एक कितना टाइप हो सकते हैं? This can be of two types. I'll need that one. Let's be humble. Okay, I'll do that at the top. Now, the electrode potential, it can be of two types. Okay. Now, here, what was happening? The zinc was going into the solution as zinc ion. Okay. As a result of which, the electrode becomes negatively charged with respect to the solution. Fine. So, if the electrode is negatively charged with respect to the solution, okay, and here, actually, what is happening? It is the oxidation reaction which is taking place here, isn't it? The metal is going into solution as ion, so it is the oxidation reaction which is taking place. So if it is oxidation reaction taking place, then the potential which will be here, this will be called the oxidation potential. Okay, so this is the first type of electrode potential, and this is your oxidation potential. And what is the other option that is left? Okay, now let us suppose the reverse process is happening. Okay. I'll take the same one. Okay, I could have taken some other substance also, but I'll take the same substance. Okay, let us suppose here we have taken up zinc. Okay, in its salt solution, let us suppose zinc sulfate is here. Fine. Now, let us suppose the reverse process. Zinc from the solution takes up to the electron from here and deposits as zinc solid. Okay, and here it was zinc ion. Fine. Now, this one we are supposing. Here, this is your oxidation potential. In the case of oxidation taking place at the electrode, then we have the oxidation potential. Fine. Now, the reverse is happening. Zinc from the solution takes up 2 electrons from here and deposits as zinc solid. Fine. In that case, from the electrode, what is getting removed? The electrons are getting removed. If the electrons are getting removed, the charge which will accumulate on the electrode will be positive. Okay. Fine. Where does the electron go? Electron does not go into the solution. However, they will neutralize the zinc ion. Fine. But in the solution, we have the sulfate ion present. Okay. Since the zinc is being removed from the solution, okay, the solution becomes negatively charged. The solution becomes negatively charged due to the presence of sulfate ion. Because sulfate ion का concentration बढ़ जाएगा, as compared to the zinc ion. Okay. So the solution will no longer be neutral, because the zinc ion is getting removed. Okay, so the solution will become negative charge with respect to the electrode here. Fine. Now here also, it's not that only the zinc ion will deposit as zinc metal. Okay, some of the zinc metal may also go into the solution as the zinc ion. Okay, leaving some of the electron on the electrode. Fine. So here also the reverse may happen. Okay, and if the reverse may happen, then ultimately an equilibrium will be established and we'll have a difference of potential set up between the electrode and its ion in the solution. Here also we have a difference of potential getting set up. Okay, a difference of potential getting set up here also. Fine. Now, in this case also, this will be called electrode potential. Okay, this is also electrode potential. Fine. But what is happening in the electrode? Is it undergoing oxidation or it is undergoing reduction here? Since it is undergoing reduction here, the potential which will be here called is your reduction potential. Okay, fine. Now remember one thing. If we have the same substance undergoing oxidation or reduction, यहाँ पर same substance दिया था, ठीक है? Their numerical value will be always same. For example, in case of the zinc, okay, the reduction potential has a value of minus 0.76 volt. This is the reduction potential. Okay, this is the reduction potential. Fine, and the oxidation potential will also have the same value, 0.76 volt with positive sign. Okay, this is your oxidation potential. Fine. The oxidation potential, or we'll talk in terms of reduction potential only. Okay, the reduction potential may be either negative. Okay, it may be positive or it may be zero also. Fine. Normally, if the metal is highly reactive, okay, above the hydrogen in terms of its reactivity, then it will have the negative value of the reduction potential. And if they are less reactive, okay, for example, copper, okay, and other non-reactive metals, in that case, the reduction potential will have the positive value. Fine. तो वो ऐसा नहीं कि सबका नेगेटिव वैल्यू होगा, डिपेंड करता है कि कितना रिएक्टिव है, उसकी टेंडेंसी कितनी है इलेक्ट्रॉन लूज करने की. If they have the tendency greater than hydrogen to lose electron, then the reduction potential will be negative for them. Okay, and if they have lesser tendency to lose electron as compared to hydrogen, then they will have the reduction potential which will have the positive value. Right? तो ये हमारा दो चीज समझ गया क्या कि जो इलेक्ट्रोड पोटेंशियल होता है वो क्या होता है, difference of potential which is set up between the electrode and its ion in the solution. Fine. It may be regarded as the tendency of the metal to lose the electron, lose or gain electron, okay, with respect to its ion in the solution. That's the electron potential. Okay, fine. तो दूसरा का हमारा reduction potential होता है, ठीक है? अगर oxidation potential कब होगा, अगर हमारा electrode का oxidation हो रहा है, और reduction potential कब होगा, अगर हमारा electrode का reduction हो रहा है, ठीक है? That means if the electrode is negative with respect to the solution, in that case we have the oxidation potential set up. Okay, and in case we have the electrode positive with respect to the solution, in that case we will have the reduction potential set up here. Fine. So this is your electrode potential. ये हमें समझ में आ गया, ठीक है? अब look here. When we talk about this tendency to lose electron or this tendency to gain electron, these are not absolute tendency. ठीक है? कोई भी substance है, ठीक है? कोई भी element है, उनका इलेक्ट्रॉन लूज करने का या इलेक्ट्रॉन गेन करने का कोई एब्सोल्यूट टेंडेंसी नहीं होती, ठीक है? इट्स ओनली व्हेन दे आर in combination with some other substance, then they will have the tendency to either gain or lose electron. Fine. तो ये जो टेंडेंसी है इनका, ठीक है, जो मतलब द ऑक्सीडेशन टेंडेंसी या रिडक्शन टेंडेंसी, ठीक है, वो कोई एब्सोल्यूट टेंडेंसी नहीं है, ठीक है? तो यहाँ पर जो ऑक्सीडेशन पोटेंशियल या रिडक्शन पोटेंशियल है, ठीक है ना, इसको मेजर कैसे करेंगे? ठीक है, इसको मेजर करने के लिए हमें क्या करना पड़ेगा, एक रेफरेंस लेना पड़ेगा, ठीक है? We have to take a reference, okay, and with respect to which we will measure this oxidation potential or the reduction potential, or we may say that we will measure the electrode potential. Right? So there are different ways to calculate it. Find out this one. Okay, one of the ways is to consider the hydrogen electrode, which is taken as the reference electrode. Okay, and the potential which is chosen for the hydrogen is 0 volt. ठीक है? और उसके रेस्पेक्ट में जब उसको हम लोग कोई भी हाफ सेल से कनेक्ट करते हैं, these are half cell basically. जो ऑक्सीजन, ये अगर ऑक्सीजन इसका हो रहा है हाफ सेल, ठीक है ना, ऐसा जो रिडॉक्स कपल हो गया, ठीक है, जो एक रिडॉक्स कपल बोलते हैं उसको हम लोग हाफ सेल बोलते हैं, ठीक है? तो दो हाफ सेल हम लोग कनेक्ट करेंगे, ठीक है, जिसमें एक ऑक्सीजन हो रहा है, दूसरा रिडक्शन हो रहा है, तो दे विल कंबाइन टुगेदर फॉर्म द इलेक्ट्रोकेमिकल सेल और द गैल्वेनिक सेल. फाइन. इतना I hope it is clear till here. Okay. So let us discuss it further. Okay. How to find out this electrode potential? Okay. To find out the electrode potential, we need a reference electrode. To find out the electrode potential, okay, which is called a reference electrode. And the reference electrode that we normally use is your standard hydrogen electrode, or we call it as the normal hydrogen electrode, okay, or simply hydrogen electrode, fine. And the reference potential which we assign to this one is your 0 volt. Okay, so that means when we combine the standard hydrogen electrode with any half cell, then whatever the potential difference that we will be getting, that will be the potential for that particular electrode. Okay, and that will give us the method for the reduction potential. Okay, fine. Reduction potential और जो ऑक्सीडेशन पोटेंशियल, ओके, दोनों को फाइंड करने के लिए कोई अलग तरीका नहीं है. It's only same only when you what you call it, find the potential. Okay, the formula which you have used will decide whether you are finding out the oxidation potential or the reduction potential. Fine. So let's see how we can find out. I'm not giving you the description, but I will let you know कैसा होता है. This is, let's say, an arrangement where we have HCl solution taken, okay, which is 1 molar. And remember that whenever we measure the standard electrode potential, okay, the concentration of the solution is 1 molar. Fine. So when we take the concentration as 1 molar, then we get the standard electrode potential. Okay? And the temperature at which we measure this one is 25 degrees Celsius. Okay, that is 298 Kelvin. Okay, this is the temperature at which we measure the standard electrode potential. Fine. Now, in this case, we have an arrangement here. The drawing may not be very good. Okay. Is mercury filled here? Okay, this is platinum wire. Okay, this is your platinum electrode, or the wire may be any. Okay, this is basically platinum electrode of unit area, which is coated with platinum black. Okay, so just to increase the surface area. Fine. And here we have an arrangement through which we can pass H2 gas at 1 atmosphere. Fine. So this is HCl solution, and here we are passing the H2S gas. So whatever the reaction takes place, it will be taking place at this electrode. Fine. The oxidation reaction or the reduction reaction will be taking place at this electrode. Okay. Now, when this electrode, the reference electrode, will be behaving as the oxidation half cell, in that case, it will be undergoing oxidation, and the reaction that will be taking place here is H2 will go into the solution as H plus. Okay, this is the reaction which will be taking place here. Fine. And when this reaction or this electrode will be behaving as the reduction half cell, in that case, the reaction that will take place here is 2H plus will take up 2 electrons and be passed as. Fine. So the hydrogen electrode, it can act as the oxidation half cell also, and it can act as the reduction half cell also, depending upon with which it has been combined. If it has been combined with a metal, okay, which is more reactive than hydrogen, then it will start behaving as the reduction half cell. Okay, and if it is connected to another half cell, okay, which is less reactive than hydrogen, then it will start behaving as the oxidation half cell. Fine. Okay, so depending upon with which it has been connected, okay, it can either act as the donor of electron or it may act as the acceptor of electron. ठीक है? क्योंकि जो ये tendency होगा जब भी जो what do you call it, the oxidation tendency or the reduction tendency, okay, these are not absolute tendency, it's only a relative tendency. Only when we have a combination of two, let's say different type of, let's say arrangement, where one is having the lesser tendency to donate electron as compared to another one, ठीक है? तो अगर उसका lesser tendency है तो दूसरा से उसका इलेक्ट्रॉन एक्सेप्ट करना पड़ेगा, अगर उसका इलेक्ट्रॉन लूज करने की टेंडेंसी ज्यादा तो वो इलेक्ट्रॉन लूज करके दूसरे को इलेक्ट्रॉन डोनेट करेगा, ठीक है? So this reduction or the redox tendency is not an absolute tendency, but it's a relative tendency. So we have to see the combination, how the combination has been done or how the combination has taken place. Fine. तो इतना तो हमारा हो गया ये, ठीक है ना? तो ये हमने समझ लिया कि what is your reference electrode. Fine. Now अब हमें इसको क्या करना है? इसको कनेक्ट करना पड़ेगा किससे? दूसरे एक हाफ सेल से, ठीक है? जो हमें उसका इलेक्ट्रॉन पोटेंशियल बताया, ठीक है? तो अब हम लोग क्या करना है? To find out the electron potential, we need to connect this half cell, the reference electrode, with another electrode, okay, whose potential has to be measured. So reduction potential has to be measured. Let us suppose we put here zinc sulfate. Okay. Now, when we have to measure the standard value of the electron potential, then remember that the concentration of this one also has to be 1 mole. Okay, this is the standard reference value. Okay, where the concentration is taken as 1 mole. 1 mole concentration हमें लेने पड़ेगा, ठीक है? और temperature हमने पहले तो डिस्कस कर लिया, that should be 25 degrees Celsius. Okay, this is the temperature that needs to be maintained, and the concentration has to be of 1 molar solution of a different electrolyte. Fine. Now, इसमें हमने एक zinc electrode डाल दिया. Okay, this is the zinc electrode. Okay, now let us suppose this is the solution. This is your zinc sulfate solution, okay, and this is your zinc electrode. This is your zinc electrode, okay, this is your standard halogen electrode, fine. Now, these two needs to be connected, let us connect this one. With the help of a voltmeter, we have connected. Okay, so whatever the deflection will be seen, that will give us the voltage of the. इसका तो zero हो गया, तो जो भी हमें deflection मिलेगा, जितना भी voltage मिलेगा, that will be the voltage on this particular half cell. Fine. Because the reference cycle for this one, the voltage is 0. Fine. Now, so in this way, if you make the connection, the cell will not function, the cell will not work. The reason is the circuit is not getting completed. Okay, so the electrodes are connected via wires. Okay, and the solutions to complete the circuit is connected via the solid bridge. Okay, this is the solid bridge. Fine. Solid bridge is a U-shaped tube which is filled with some kind of gel, okay, which is conducting in nature. Now, for this one, what we do is we take the agar, okay, this is a gel organ, okay, in which some kind of electrolytes are added. Okay, the electrolytes normally they should have a similar ion mobility. Okay, it can be your calcium nitrate, okay, NH4Cl, etc. Okay, so these are some of the substances, okay, which can act as electrolyte or maybe KCl. Okay. Right? So these electrolytes, they are mixed with agar in warm water, okay, and the solution is poured into this one, okay, allowed to cool down, okay, so that it forms gel-like substance, okay, solid-like substances, so that it doesn't fall away. Okay. And this is plugged with cotton. Okay, closed with cotton so that the gel doesn't fall into the solution. Okay, this is how the solid base is constructed. Okay, so basically the solid base connects the two half cells. Okay, there are other functions of solid base also. It maintains the electrical neutrality of the two half cells. Okay, so there are other functions also. Fine. So this is the use of solid bridge. Okay, the moment you connect the solid bridge, okay, the moment you put the solid bridge here in the two half cell, okay, you connect the two half cell, you will see some kind of deflection here. Okay, you will see some kind of deflection here in the voltmeter. Fine. Now it will give you the voltage. Okay, the voltage which is seen here is 0.76 volt. Okay, and this is the voltage of the gym. Okay, now when I have constructed here, I have not followed the convention. Okay, normally the oxidation half cell is put on the left hand side, the reduction half cell is put on the right hand side. Okay, now in this case, the direction of the electron is this one. Okay, in this direction the electron will move, and this is the direction of the conventional current, that is your I. Fine. This is the direction of the conventional current, and this is the direction of the electron current. Okay. So that means the electrons are being generated here. So this is negatively charged. This electrode is negatively charged with respect to the solution. Okay. And this is positively charged with respect to the solution. Fine. And how this will be negatively charged? If we have, okay. This will be only possible with oxidation reaction taking place. G is going to the social G plus plus, and the electrons can remove here. Fine. So if we have the oxidation reaction, this is the oxidation half cell, and this will be your reduction half cell. Okay. In this case, the two hydrogen ion will be taking up two electrons and depositing as H2 gas. Fine. So here the reduction reaction will be taking place, and this will be called the reduction half cell, and this will be called the oxidation half cell. Fine. Now, wherever the oxidation reaction takes place, that is called the anode. So this will be your anode. Okay. And wherever the reaction takes place, that will be called the cathode. Okay. Do not confuse yourself with the anode and cathode in the electrolytic cell. Okay. In that case also, in electrolytic cell also, wherever the oxidation takes place, that is the anode. Fine. So remember, whether we have the electrolytic cell or whether we have electrolytic cell or whether we have the galvanic cell, in both the cases, जो भी half cell में हमारा oxidation हो रहा होगा, ठीक है, that will be the anode and the other will be the cathode. Fine. So this is your anode and this is your cathode, and this is the reaction which will be taking place at the cathode. Anode, and this will be the reaction which will be taking place at cathode. Now, what will be the reduction potential here of the zinc? I'll clean this now. How to find out the reduction potential now? Okay, the voltage which we have got here is 0.76 volt. Okay. Now, this was the setup. Okay, so the E of cell equals to E cathode minus E anode. Okay, if you use this formula, then you will be getting the reduction potential. Fine. So what is the E of the cell? You have a 0.76 volt equals to E cathode. Cathode was your hydrogen. Okay. What is the voltage for this one? That is 0. Is standard cathode. E naught minus E anode is your standard E naught. So E naught anode will be equal to minus 0.76 volt. This is the reduction potential for the zinc electrode. Okay. Now, how do we represent the reduction potential? To represent the reduction potential, we write it like this one: E naught. This is standard. Okay. Here, the term that we use is Zn plus plus. Okay. Reduction is taking place, so it is undergoing reduction. If you write it in this way, that means it is your reduction potential which we are mentioning. Okay, and the sign here is negative in this case. Okay, so this is the way we represent the reduction potential. Fine. And the resistance potential for the zinc is here minus 0.764. Okay, this is how we will be representing. And for convention nowadays we use the reduction potential only. Okay, in some of the old book you might see the oxidation potential, but most of the questions that are asked and in your inside book also, okay, they'll be using the reduction potential everywhere. Okay, so if nothing is mentioned, that means it must be your reduction potential. Fine. So that's all for today. And in the same way, you can find out the reduction potential for all the metals. Okay, you can find out the half cell. Okay, the connect that half cell with the standard hydrogen electrode, whatever the voltage you will obtain. Okay, using this formula, you will get the reduction potential for that particular arrangement. Okay, or that for particular half cell. Fine. And these electrode potentials are arranged in a series, which can be either always so they are increasing the reduction potential or they are decreasing reduction potential. Okay, mostly it is expressed in terms of the decreasing reduction potential. Okay, the one which has got lowest reduction potential, okay, means most negative value of reduction potential. Okay, that's your lithium. Okay, that means it has very less tendency. जितना ज़्यादा negative value होगा, उतना कम tendency होगा इलेक्ट्रॉन accept करने का. ठीक है, और जितना ज़्यादा पॉजिटिव वैल्यू होगा उतना ज़्यादा टेंडेंसी होगा इलेक्ट्रॉन को एक्सेप्ट करने का. ठीक है, तो उसके बेसिस पे इलेक्ट्रोकेमिकल सीरीज, इसके बेसिस पे हम लोग वी जनरेट द इलेक्ट्रोकेमिकल सीरीज. फाइन, एंड दैट विल हेल्प यू in many ways, okay, to understand the electrochemistry. Fine. So that's all for today. We'll meet again tomorrow with new topic.